There was a sense of competition, but it was what I would call friendly competition. I mean, can you imagine two athletes? They are in the same training camps, they help each other, they even give tips to each other, but then when it comes to the race, everybody wants to be the first.
The rival groups were both using magnetic trapping and lasers to cool their atoms. But for the final push towards absolute zero, to turn these atoms of gas into the quantum state Einstein had predicted, they needed one more cooling technique: evaporative cooling.
It's just like with this coffee. The steam coming off the coffee is the hottest of the coffee molecules escaping and carrying away more than their fair share of energy. In the case of the atoms, we keep the atoms in a sort of magnetic bowl, and we confine the atoms there. They zoom around inside the bowl, and then the hottest ones have enough energy to roll up the side of the bowl and fall over the edge, slop over the edge, taking away with them much more than their fair share of energy, and the atoms that remain have less and less energy, which means they move slower and slower and start to cluster near the bottom. And as that happens, we gradually lower the edges of the magnetic trap, and always, so there's just a few atoms that can escape, until finally the remaining atoms cluster near the bottom of the bowl, huddled together. They get colder and colder and denser, and eventually in this way evaporation forces the Bose-Einstein condensation to occur.
The race to produce a Bose-Einstein condensate was intensifying.
At every major meeting, Eric Cornell and I gave talks or talked to each other. We were keenly aware that we were both working towards the same goal.
In June 1995, the Boulder Group was working round the clock, knowing that MIT and several other labs were also poised to produce the first condensate. An official visit from a government funding agency was the last thing they needed.
We didn't want to close down the lab or clean up our lab or put up posters. We wanted to work very hard. So the senior dignitaries in the three-piece suits and so on came in to the lab, and we left the lights off, and everyone continued to work. And I made them keep their voices down and talked to them rather in a hurried way, and then sort of shuffled them out the door. And they all had a slightly puzzled look on their face, because it probably had never happened to them before in the history of being a visiting committee, that they were treated with as little pomp. And later I actually met one of the guys who said, I suspected something was up that day, because otherwise you never would have dared to do that.
June the 5th, 1995, turned out to be a big day in the history of physics. The Boulder Group seemed to have made what Einstein had theorized 70 years before, a Bose-Einstein condensate.
Our first reaction was, wait, we got to be careful here, let's think of all the different knobs we can turn, checks we can make, and so on, to see if this really is Bose-Einstein condensation.
Condensate is sort of like a vampire. If the sunlight even once falls on it, it's dead. And so its realm is the realm of the dark. But we can take pictures of them because we strobe the laser light really fast, and even as the condensate's dying, it casts a shadow, and the shadow is frozen in the film.
At a temperature of 170 billionth of a degree above absolute zero, Wyman and Cornell created a pure Bose-Einstein condensate in a gas cloud of just 3,000 atoms of rubidium, the first in the universe, as far as we know.
One of the first things you need to understand about Bose-Einstein condensation is how very, very cold it is. Where we live at room temperature is far above absolute zero on this scale. Imagine that room temperature is represented by London, thousands of kilometers from here. Then on that scale, if we imagine right here where I'm standing in Boulder is absolute zero, the coldest possible temperature, then how close are we to absolute zero? If we think of London as being room temperature and right where I am is absolute zero, then Bose-Einstein condensation occurs just the thickness of this pencil lead away from absolute zero.
Within months of the Boulder Group's success, Wolfgang Ketterle produced an even larger condensate from 500,000 sodium atoms, slowed down to a virtual standstill, causing their wave functions to overlap to produce an entirely new state of matter. At last, quantum mechanics was more than just a theoretical construct. It was something that could be seen with the naked eye. Cornell, Ketterle, and Wyman shared the Nobel Prize for Physics in 2001.
One of the things the Nobel Prize means, and the ceremony means, that everybody remembers Eric's the person who forgot to bow to the king.
There was a breakdown of protocol on my part. There was no excuse because they actually drill us. It's more like you have a series of rehearsals practicing how to bow to the king, and I somehow managed to bollocks it up at the last possible moment. And I thought maybe, Carl, who came after me, would do this, make the same mistake, and then no one would figure it out. But no, he was perfect.
I heard about the Nobel Prize when I was woken up by a telephone call, which was at, I think, 5:30 in the morning. So you wake up, you go to the telephone, and somebody tells you, congratulations, you've won the Nobel Prize. You're still tired, your brain is not fully functional, but you realize this is big, and what you feel is pride for MIT, your collaborators, for yourself. It's wonderful to see that your work gets recognized and acknowledged in this way.
Like any great adventure, the pursuit of science offers no guarantee of success. But for the godfather of ultra-cold atoms, persistence eventually paid off. In 1998, after 20 years of struggling to obtain a condensate in hydrogen, Dan Kleppner finally succeeded. For a few fleeting moments, his dream came true.
Of course, we were delighted, and I think everyone was delighted, because we'd been working on it for so long. It's kind of embarrassing to have this group which helped start the work and was working away there fruitlessly while everyone was enjoying success. When we got it, everyone was happy.
To see that an effort which lasted for 20 years, which took so much patience, frustration, and tenacity, to see that succeed is just emotional, it's liberating. I will never forget this standing ovation which Dan Kleppner received at the Varenna Summer School when he announced Bose-Einstein condensation in hydrogen.
Everybody just got up and it was sort of like an opera where everybody just cheered and people were crying, and because everybody realized that they had finished the race, but too late. And it wasn't going to work out, but in some sense they had really stimulated the whole field. So it was a very moving moment.
For the pioneers who had realized Einstein's dream and created condensates, it was the end of an extraordinary decade of physics. Now there was a new challenge: to work out what to do with them.